Okay, so number 1 on the quiz was a 2-variable 2-equation system, but they were not linear.
Not gonna lie, I panicked when I saw that.
You should. So you can't solve these with matrices, and you do not have the nice rule that there's going to be one solution. You know, parabolas and lines can intersect more than once. So because these are not linear, they do not follow a lot of the patterns we had been studying. But it's still pretty easy to solve algebraically. We can substitute. We can throw this in for y here. So x squared minus x plus 2 minus 2x equals 2. So if you get that equal to 0 and combine like terms, you get x squared minus 3x equals 0, where a lot of people got to that, but then did not successfully solve it, which should not happen. We factor an x out. That leaves you with an x minus 3. So you either have x equals 0 or x equals 3. So there are two solutions, as there should be when a parabola and a line intersect. So then you got to plug those back in to solve for y. So when you plug 0 in, you get a y value of 2. So there's one ordered pair. When you plug 3 in, you get a y value of 8. So there's your other ordered pair, yeah?
Yeah.
Any questions on number 1? Bam.
I did too. I was gonna run out of
Okay. Number 2 is a 3-variable 3-equation system, and these are all linear. So then all of those patterns can be true. It's either going to be one solution, no solution, infinitely many points on a line, or infinitely many points on a plane. And this is the one that ends up having one solution. I picked some really nice numbers here, so it turns out the row reducing on this was really easy. So you go -1, 1, -3, -6, 1, -1, 4, 9, 2, -3, 1, -4. I can multiply this first equation by a 2 and add it to the third equation. So I'm going to have -1, 1, -3, -6, 1, -1, 4, 9, 0, -1, -6. No, it's not. That's -5. And -16. -16. -5. Wow. I said -5. I thought -5. My hand sometimes doesn't do what I tell it to. Shush. Then we can just add rows 1 and 2 together. So it's going to give you -1, 1, -3, -6, 0, 0. Wow. 1, 3. 0, -1, -5, -16. And so what happened was, one step earlier than I would have expected it to, we actually are in REF. Now technically it's not REF right now, but I can just take row 2 and row 3 and switch them, and it would be an REF. Agreed? So that second equation right there tells us that z equals 3. I can plug that into the bottom equation. -y minus 15 equals -16. So -y equals -1, so y equals 1. Then you get -x plus 1 minus 9 equals -6. So that gives you a little something like -x equals 2. So you add an 8 to both sides. So x equals -2. So you should have gotten the point -2, 1, 3. A lot of people got 3 for z, but then got their x and their y wrong. So I don't know what exactly happened there. Any questions on number 2?
No. You're free.
Really weird. Okay, number 3. I tried to make it obvious for you, not make it too complicated, also save you a little bit of work. I just gave you a 3-variable 2-equation system. So guaranteed this is either infinity or 0 solutions. If planes are parallel, no solution. If they intersect, one solution, and it's going to be a line. If they're the same plane, infinitely many again, but on a plane instead. So you can still put this into a matrix. One, 2, 3, -1, 2, 3, -1, 2. So if we multiply this first row by -2 and add it to the second row, The first row is going to be 1, 2, 3, negative 1. The second row is going to be 0, negative 1, negative 7, and 4. And that's your REF. Besides maybe calling this positive 1, positive 7, negative 4. That's REF. And so we'll stop right there. The second equation has the variables y and z. So you pick one and just call it whatever you want. I'm going to pick z, and I'm going to call it the parameter t. Yes?
Wouldn't it be 4? I mean, not 4 is 0.
Yes, it's 4.
No, wouldn't it be 0?
Negative 1 times negative 2 is positive 2. 2 plus 2 is 4. Okay. So now that z is t, and I think most people chose to call z the parameter. And some people did, but some people did y. You did it correctly. Some people did x and did it correctly. You really did do it correctly. You just made a minor algebra mistake. That was nothing. So then we can plug t in for z. So that's negative y minus 7t equals 4. So negative y equals 7t plus 4. So y is negative 7t minus 4. And then we can plug in to find x. X plus 2y plus 3z equals negative 1. So that's going to be x minus 14t minus 8 plus 3t equals negative 1. X equals, we can add an 11t to both sides, add an 8 to both sides. So you should have gotten the parametric equations x equals 11t plus 7, y equals negative 7t minus 4, and z equals t. And again, you could have gotten other answers if you chose to let y equal t. Or maybe you're just feeling crazy and you wanted to call z like 2t plus 1. You can. Yeah, I didn't know.
Yeah. I said.
Okay.
I said, but you say.
Cool? The what? Yeah. It's pretty good. Yeah. It said like tau halves, which is pi.
What's our average on